Something strange is hanging above our heads. Not a UFO, not a comet we've seen before, not even one of those interstellar tourists we've recently gotten used to. No, this one feels different. It moves different. It looks different. And the more scientists study it, the more the mystery deepens. They named it Atlas, the third confirmed interstellar object in human history. And to be honest, if the universe wanted to drop a cosmic riddle right in our backyard just to mess with us, this would be exactly how it'd look. The story begins in July 2025, when a faint, needle-thin streak appeared in telescope data coming from the outskirts of Jupiter's orbit. At first, astronomers thought the software was glitching. The object was coming way too fast, fast enough that it shouldn't belong to the Sun at all. Then the calculations came in. 58 kilometers per second, nearly double the speed you'd expect for a normal comet drifting lazily into the inner solar system. Right away, everyone knew this thing wasn't one of ours. It was a visitor. But unlike the famous Oumuamua or Borisov, Atlas wasn't shy. It wasn't small. And it wasn't sliding in from some steep, tilted angle. Instead, it approached our solar system like a giant stone skipping across a lake, low, level, almost parallel to the planets themselves, with only a 3-degree tilt. That's almost nothing. It's like it lined itself up deliberately, aiming for the exact plane where all our worlds orbit. Maybe coincidence, maybe not. That's the kind of thought scientists never say out loud. But you know it's floating around in the back of someone's mind. Then came the size estimate. 5 kilometers across. 5. That's bigger than some small moons. Immediately, the story changed from a weird rock passing by to Boto. This could rewrite everything we know about the Milky Way's deep past. Because the orbit didn't just reveal where Atlas was going, it revealed where it came from. When researchers traced its path backwards, way backwards, they realized this thing had drifted through the dark of our galaxy for millions of years, 10 million to be specific. And in all that time, as it passed near roughly 90 different stars, it barely interacted with any of them. No strong gravitational pulls, no altering of its direction, just a nearly perfect straight shot toward our Sun. To understand how weird that is, imagine throwing a paper airplane from New York and having it land in Los Angeles without drifting more than a few inches left or right. That's the level of how is that even possible we're talking about. What makes it even stranger, the region Atlas came from, the thick disk of the Milky Way, is ancient, older than our Sun, older than the planets, filled with relics from the early galaxy. So, maybe Atlas isn't just a visitor. Maybe it's a fossil, a time capsule from an era before Earth even existed. If that doesn't send a chill down your spine, hang on. This is where things get seriously weird. As Atlas moved closer to the Sun, astronomers expected it to warm up slowly, release a bit of gas, maybe develop a normal comet tail. But instead, something happened way earlier than it should have. It sprouted a tail, a huge bright one, long before it reached the heat zone where comets usually wake up. That alone was puzzling. But then came the shock. The tail wasn't pointing away from the Sun. It was pointing toward it. Comets don't do that. They literally can't. Solar radiation pushes material outward like a wind blowing dust off your hand. But Atlas was blowing against the wind. Scientists double-checked the instruments. They checked the models. They checked the geometry of the sunlight, the observation angle, the calibrations. Every explanation failed. You don't forget a moment like that. It's one of those rare times in science when the entire field leans forward at the same time, whispering the same question. Okay, what are you? When spectroscopy data finally came in, the plot thickened even more. The gas escaping from Atlas was chemical chaos. It showed extremely high levels of carbon dioxide, nearly 8 times more than the water vapor. That's the opposite of what normal comets do. It's like opening a soda can and finding out it's mostly gas. Barely any liquid. And as Atlas approached the Sun, something even stranger happened. Its composition started to change. The water levels rose. The CO2 ratio dropped. It began to behave more like a traditional comet. It was like the object was shedding layers, almost like revealing different ages of itself, one shell at a time. A frozen fossil melting back into something familiar, or a familiar object concealing something deeper. But the weirdest twist wasn't chemical. It was optical. When light reflected off Atlas's surface and hit our telescopes, it produced what scientists call negative polarization. That sounds technical, but here's the simple version. Ordinary rocks, dust, ice, basically all natural surfaces scatter sunlight in predictable ways. Atlas didn't. Its light behaved like it was bouncing off something incredibly fine-grained, almost engineered, or at least extremely unusual for a natural object. No one wanted to say the A word, though, of course. Nobody wants to be the scientist who screams, "Maybe it's alien," on national TV. But the whispers were there. Not definite, not even confident, but undeniable. Meanwhile, Atlas kept gliding inward like it was touring the solar system on autopilot, brushing the edges of planetary orbits, passing so close to Mars that every space agency on Earth started scrambling. October 3rd, the day Atlas flew near Mars, 0.19 astronomical units away, close enough that our machines on Mars very likely saw it. Perseverance rovers, the MAVE-N orbiter, the ExoMars TGO spacecraft, all of them were in perfect positions to capture once-in-a-lifetime data, except one problem. NASA's operations were frozen because of the US government shutdown happening at the time. A real "you've got to be kidding me" moment in the middle of a cosmic event that may not repeat for centuries. Even now, nobody knows if those spacecraft actually recorded Atlas. If they did, the data isn't public. And if they didn't, that golden window is gone forever. Then came the most painful moment of the entire story. The moment Atlas reached perihelion, its closest point to the Sun. The moment we should have seen its true behavior, its full outgassing, its structure, its rotation, everything. And just our luck. The Sun blocked it completely from Earth's line of sight. We got nothing. Imagine the universe handing you a sealed envelope with the answer to a cosmic mystery. And then the Sun just sits there on top of it like, nah, try again next century. Now Atlas is flying outward again, cooling, slowing, fading. But is not disappearing just yet. In December 2025, it will pass relatively close to Earth, close enough for our best observatories to catch it with fresh eyes. Then, in March 2026, it'll swing near Jupiter, giving the Juno spacecraft a possible front-row seat to the most intriguing interstellar object since Oumuamua. What we learn from those encounters could answer some of the biggest questions we've ever asked. Where do these visitors come from? Why do they drift between stars? How common are they? And could they carry the building blocks of life between worlds? Because if matter travels between stars, then life might too. And that idea, panspermia, is no longer science fiction. Interstellar objects like Atlas make it feel strangely possible. Maybe normal. Maybe inevitable. And as Atlas drifts away, leaving us with more questions than answers, you can almost sense the universe whispering to us, like an old storyteller. You're not finished. Keep looking, there are more secrets coming. And honestly, with how weird our cosmic neighborhood is becoming, I kinda believe it. Before we dive into part 2, where things get even stranger, don't forget to subscribe and hit the like button. It helps this channel explore more mysteries like this, without getting lost in the algorithmic void. And trust me, you really want to hear what happens next. If you thought the first part of Atlas's story was strange, buckle up. Because this is the portion where the questions get sharper, the data gets weirder, and the scientists, who are normally calm even when the universe throws a tantrum, begin sounding genuinely unsettled. When Atlas passed Mars, it left behind more than speculation. It left a trail of clues, subtle fingerprints hidden in its gas emissions, its thermal signature, its spin behavior, clues that didn't fit neatly into any known category of comet, asteroid, or interstellar rogue. And the moment it slipped behind the sun, vanishing just when we needed it most, research teams around the world began racing to make sense of the fragments of information they already had. Because Atlas wasn't just moving, it was evolving. Imagine an ancient stone carried across the galaxy for millions of years, slowly heating, cracking open, shedding layers like a creature waking from hibernation. Atlas felt like that, an object that wasn't just passing through, but changing in real time. But what exactly was changing? Let's start with its rotation, something astronomers obsess over. Because rotation tells you almost everything: structure, density, surface roughness, age, even whether something inside is hollow or solid. At first, Atlas spun slowly, gracefully, almost lazily, once every 16 hours. That's typical of large comets. But then, as the object approached the inner solar system, its rotation began to drift. Not speed up, not slow down, drift. Small moments of torque, like tiny hands pushing at microscopic angles, nudged it off its original spin axis. These nudges did not match sunlight pressure. They did not match gas jets from sublimation. They did not match any model scientists ran. It almost looked intentional. Not in a sci-fi way. Nobody's claiming that. But intentional in the sense that something internal was shifting its mass distribution. Something about Atlas was rebalancing itself. And if that doesn't raise eyebrows, here's where you might want to sit down. As it got closer to the sun, its outer shell began shedding material in quiet, controlled bursts. Not chaotic explosions like a normal comet, but slow, periodic releases. Every few days, a bloom of CO2, a sprinkle of dust, then silence, then repeat. It was behaving like a layered object, not a monolithic rock, not a loose rubble pile, something in between, something ancient enough to have crusted over, but structured enough to outgas rhythmically. The big question scientists couldn't shake was this: how did something that formed in the thick disk of the galaxy, an ancient turbulent region full of dying stars and violent radiation, end up preserving such delicate features? It's like finding a snowflake in the middle of a furnace and realizing it somehow didn't melt. And the deeper astronomers dug into Atlas's composition, the stranger the picture became. The initial CO2 to water ratio, 8:1, was unheard of. But what shocked researchers wasn't just the ratio, it was the timeline. The CO2 levels were high when Atlas was still far, far from the sun, way too far for carbon dioxide to sublimate easily. Then, as it warmed, The water levels began rising, but in a pattern that suggested the ice had multiple distinct layers, almost like geologic strata inside a comet, except the layers didn't match any known formation process. Think about sediment layers on Earth. Each layer tells a story of an era, an environment, a climate. Now imagine sediment layers, but formed between stars, in deep space, under cosmic radiation so intense, it should pulverize structure. So what kind of object could survive that trip intact? Some scientists proposed that Atlas formed inside a dead protoplanetary disk, a kind of ghost nursery where planet fragments swirl for billions of years. Others suggested it was once part of a shattered dwarf planet ejected from its home system long before our Sun formed. A few even whispered the idea of ancient collisions in the Milky Way's thick disk, creating objects unlike anything we've catalogued. But the most radical idea, the one that mainstream scientists won't attach their name to, but quietly admit is mathematically possible, is that Atlas could be a remnant from a pre-solar cluster, a fragment from a star system that lived and died before our Sun existed. If that's true, then Atlas isn't just older than Earth, it's older than Earth's birth cloud, older than everything we recognize, the equivalent of a cosmic elder wandering into our solar system, like a traveler returning to a land that didn't exist when they first set out. And this idea came into sharp focus when a group of astronomers analyzed Atlas's trajectory with high-precision galactic models. The path wasn't random. It traced back to a quiet, ancient region of the Milky Way, where stars move in thicker, more stable orbits, far from the chaotic spiral arms we inhabit. Stars in that region are survivors. Long-lived, metal-poor, stable for billions of years. And if Atlas spent millions of years drifting from there to here, it means the object witnessed eras of the galaxy we can only imagine. Perhaps it passed through supernova remnants. Perhaps it skimmed the edge of broken solar systems. Perhaps it carried dust from stars that have long since collapsed into white dwarfs. Then there's the light polarization, a clue that still has scientists losing sleep. Negative polarization at small phase angles isn't unprecedented, but Atlas's signature wasn't just negative. It was too negative, sharper than expected, deeper, almost like the light was bouncing off a surface made of particles finer than cigarette ash, packed together like a cosmic sponge. What kind of space environment could produce dust that fine? Interstellar radiation tends to shatter particles, but in dense regions, primordial molecular clouds, for example, chemistry can produce incredibly tiny grains so delicate they don't survive in typical star systems. So how did Atlas preserve them? Either its surface is younger than expected, or it's been shielded for eons by something we haven't detected yet. A crust? A hardened mantle? A shell of sintered particles? Or, more provocatively, something hollow beneath the exterior absorbing energy in unusual ways? To be clear, nobody is claiming Atlas is artificial. But the fact that these observed features allow people to even speculate in that direction says a lot about how baffling it is. Yet the weirdest sequence of questions began after the Mars flyby, the moment Atlas had already started warming, but hadn't yet reached the Sun. Astronomers noticed that the jets of gas escaping from Atlas were oriented in inconsistent directions. They didn't line up with sunlight. They didn't line up with spin. They didn't match thermal hotspots. It was as if pockets of gas were trapped inside in a maze of internal fractures. But the gas release was too smooth, too measured, for a chaotic internal structure. Every time one mystery began making sense, three new ones took its place. And then came the hardest pill to swallow. Many of the anomalies were subtle enough that without continuous observations during perihelion, the moment Atlas passed behind the Sun, we may never fully decode the pattern. That day behind the sun was a cosmic heartbreak, a solar eclipse that swallowed our answers whole. The universe dangled a key in front of us, then let it slip into the fire. And yet, as Atlas moves outward now, cooling, quieting, drifting back into anonymity, the story isn't over. In fact, many astronomers think the real revelations are still coming. Because in December 2025, when Atlas passes relatively close to Earth again, we'll catch it fresh, like a rewound tape. Cold, quiet, stabilizing. That's when we can compare before and after data and figure out what changed during its solar encounter. Did it crack open further? Did internal layers shift? Did its rotation settle or destabilize? Did its tail behavior normalize? Did the CO2 levels drop dramatically after the first few layers evaporated? But the biggest moment might come in March 2026, when Atlas swings near Jupiter. Jupiter isn't just a planet. It's a gravitational monster, an observatory built by nature, and the Juno spacecraft is perfectly positioned to capture high-resolution images and spectra of Atlas. During that pass, there's a very real chance Juno could reveal the surface texture, the layering, the nucleus shape, even cracks or cavities that hint at internal composition. If Atlas is a cosmic fossil, Juno might show the layers like tree rings. If Atlas is a fragment of a shattered world, Juno might reveal clues in its mineral content. If Atlas is something else, something we haven't even named yet, Juno might be the first to notice. And while all this scientific detective work happens, another question quietly lingers in the background. Why are we suddenly seeing so many interstellar visitors? Oumuamua in 2017, Borisov in 2019, now Atlas in 2025, 3 in less than a decade. For most of human history, we saw zero. Are we detecting them because our instruments got better? Or are these objects becoming more common? Or have they always been passing through, but something about the galaxy has shifted to send more our way? Some scientists propose that the Sun is currently moving through a denser region of interstellar space. Others think the Milky Way may be shaking loose old debris as gravitational tides ripple across the galaxy. And a few, whispering cautiously, wonder whether ancient star systems eject objects in waves, cosmic migrations that travel for millions of years before arriving everywhere at once. If that's true, then Atlas might be the first member of a larger swarm, a preview of more to come, a messenger from a population of wanderers we've never catalogued. Perhaps the galaxy is more connected than we thought. Perhaps material crosses star systems regularly, like dust in a cosmic breeze. Perhaps life's ingredients drift through the Milky Way, like pollen floating on air. If so, then panspermia, the idea that life spreads between worlds, becomes more than plausible. It becomes natural, expected, maybe even common. Atlas could be a carrier, not of life itself, but of the seeds, complex organic molecules frozen in deep time, waiting for the right environment to spark chemistry. And if that idea feels too poetic, remember this: every atom of carbon in your body, every oxygen molecule in your lungs, every metal in your blood, came from a dying star that threw its guts into space. We are already made of interstellar debris. So why shouldn't life's building blocks travel the same way? Atlas might be proof that the galaxy recycles itself endlessly, life included. And yet, as profound as these ideas are, they sit alongside one simple, beautiful truth. Atlas is leaving, quietly, gracefully, like a traveler passing through a village in the night, leaving behind only footprints and a story for those who were awake to see it. And the story it leaves behind reshapes how we think about our place in the universe. Not isolated, not special, but part of a grander flow, a cosmic exchange that's been happening long before we opened our eyes, and will continue long after we're gone. Part 3 will dive into that grand picture, what Atlas means for our future, what it says about the galaxy's hidden highways, and why this may be the beginning of a new era in astronomy, one where humanity finally learns to read the messages drifting between the stars. But before we continue this journey, make sure you hit that like button and subscribe, not just to support the channel, but because, trust me, you do not want to miss how this story ends. By the time Atlas began drifting back into the cold, a strange shift had taken place, not in the object, but in us. Scientists who once treated interstellar visitors as scientific curiosities began referring to Atlas with a tone you normally reserve for storms you can feel in your bones. Amateurs started tracking it with backyard telescopes like it was a comet carrying secrets. Even people who never cared about astronomy suddenly wanted to know, what does it mean that something older than Earth just flew past our sun? And that's the question echoing now. Not what is Atlas, but why does Atlas matter? Because what happened in 2025 didn't just give scientists a new data point. It tore open a window into the real structure of our galaxy, a structure we've been completely blind to. Let's take that window slowly. For most of human history, we thought our solar system was an island, self-contained, stable, a closed chapter in a very thick book. Then, Atlas arrived and reminded us that the Milky Way is more like a vast river, and our solar system is just a temporary eddy in its current. When scientists traced Atlas's long backward path through the galaxy, 10 million years of motion, they noticed something humbling. Atlas didn't wander, it flowed. Its trajectory aligned with the thick disk of the Milky Way, like it was riding a silent conveyor belt. This implies a staggering truth. Interstellar objects might not be random debris at all. They might be participants in a galaxy-wide circulation system, material constantly exchanged between star systems, like blood flowing through veins. Atlas was a drop in that river, a piece of ancient matter carried across cosmic distances by forces older than Earth's oceans. If that's true, then our solar system isn't isolated. It's connected, linked to distant systems we'll never see with the naked eye. And Atlas is the faint whisper of that connection. But here's where it gets more fascinating. Atlas's composition doesn't just tell us where it's been. It hints at what the early galaxy was like. The thick disk region it came from is populated by stars that formed before the Sun existed. Stars with low metal content. Stars that aged in slow, stable orbits. If Atlas originated there, its chemistry carries a fossil record of a time when the galaxy was more violent and more fertile. High CO2 content, fine dust that shouldn't survive modern interstellar radiation, layered ice from environments that don't exist today, and thermal properties unlike any known comet. The object isn't just a traveler, it's a historian, a witness to chapters of the Milky Way that our telescopes can't reconstruct. Imagine reading a book where half the pages were torn out, and suddenly, someone hands you a scrap from the missing chapters. That's Atlas. And that's why the scientific world doesn't see it as a curiosity. They see it as a messenger. A messenger from an age when planets formed differently, when star systems collided more frequently, when chemical reactions could unfold over millions of years in complete darkness. Atlas isn't just older than us. It may belong to a generation of objects forged when the Milky Way was still figuring out what it wanted to be. And that opens the door to a deeper question. A question scientists have tiptoed around for decades, but can no longer ignore. If interstellar debris can travel between star systems, can life's ingredients travel too? Panspermia, a word once relegated to late-night forums and speculative panels at science conventions. But with each interstellar visitor, that concept inches closer to mainstream. Because every time an object like Atlas passes close to the Sun, we detect organic molecules. Simple ones, yes, but ones that act as precursors to amino acids, sugars, and the chemical alphabet from which biology writes itself. What if these molecules scatter across young planets? What if they seed oceans and atmospheres? What if life isn't a local phenomenon at all, but a galactic process? Atlas might be an example of how the galaxy spreads complexity, slowly, silently, across eons, not like a spaceship, not like an alien artifact, but like pollen blown across continents. And if that's true, then Earth isn't the beginning of anything. It's part of a chain, a step in an ongoing cosmic exchange. But let's zoom out even more, beyond chemistry, beyond biology, beyond anything we normally consider. When astronomers looked at Atlas's velocity, 58 kilometers per second, they realized something chilling. It wasn't just passing by. It was cutting across our solar system with purpose. Not intentional purpose, of course, but directional purpose. Atlas wasn't wandering like a lost stone. It was maintaining a coherent course across tens of millions of years. No close stellar encounters. No disruptions. Just a long, steady glide through the galaxy. This suggests something shocking. Most interstellar objects don't come from chaotic events like star explosions. They come from the slow erosion of ancient star systems, material ejected quietly, steadily, for billions of years, like dry leaves falling from an old tree, except the leaves are chunks of planetesimals, and the tree is an entire solar system. This reframes everything. Because if ancient star systems shed material continuously, then the Milky Way is filled with a gentle rain of cosmic remnants, drifting for millions of years until gravity decides to drop one into a young planetary system like ours. Atlas is one of those leaves, a fragment of something older drifting into a system younger. It's not the first, it won't be the last, and it likely won't even be the rarest. Which leads to the next idea, one that's quietly electrifying the scientific community. What if the solar system has encountered thousands of objects like Atlas? But we never saw them. Our telescopes were too weak, our surveys too shallow, our technology too primitive. But now, we're finally looking. And what we're seeing is that the galaxy is not empty. It's not static. It's not separated. It's alive with movement, with exchange, with the travelers. Atlas is simply the first one we caught in detail. And if we want to understand our origins, not just Earth's, not just the Sun's, but the galaxies, we have to study these travelers, because buried inside them are clues to how stars formed before our Sun, how planets assembled in different environments, how chemical evolution unfolded across the galaxy, how life may have emerged, how material migrates across vast interstellar distances, how everything is connected. And here's the part nobody likes to admit. Atlas's disappearance behind the Sun hurt. It hurt because it stole answers. It hurt because it reminded us how fragile observation can be. It hurt because we finally had a cosmic visitor that arrived early enough for full monitoring. And we still missed the critical moment. But the universe is generous. Cruel, yes, but also generous. Because Atlas is leaving us with a second chance. When it passes Earth in December 2025, telescopes will be ready. When it approaches Jupiter in March 2026, Juno will be waiting. We might get the first true close-up images of a thick disk interstellar object, a picture of surface layers older than the Sun, a glimpse into cosmic history frozen in ice. And if Juno captures something unexpected, an unusual texture, a strange fracture pattern, an exotic mineral signature, it could redefine how we classify interstellar bodies entirely. Atlas might not be a comet, might not be an asteroid, might not be a planet fragment. It might be something new, a category we have no name for yet. And that's the beauty of this moment. The universe hasn't run out of surprises. We're not done discovering new types of objects. We're not done rewriting textbooks. We're not done learning. In a way, Atlas is a reminder, a gentle, ancient reminder, that we are still beginners, still children staring at the sky, asking questions too big for our language. And maybe that's the point. Maybe Atlas didn't come to give us answers. Maybe it came to give us better questions. Questions like, what else is drifting out there? How many Atlas-like objects pass unnoticed every century? Did they carry ingredients that helped seed life on Earth? Are there objects carrying more complex chemistry? Maybe even precursors to biology? Is the galaxy full of travelers exchanging molecules across star systems like threads, weaving a giant tapestry? And the biggest question of all, if life emerged on Earth, how many other worlds received the same cosmic seeds? Maybe we're not alone. Not because aliens are visiting us, but because the building blocks of life travel freely between stars. Maybe the universe wants life. Maybe it keeps trying again and again, star to star, system to system. Atlas is a tiny piece of that story. A frozen traveler carrying a message. Older than our language, older than our species, older than the sun. A message that says, you are part of something bigger. And that's why Atlas matters. Not because of the data, not because of the anomalies, not because of the mysteries, but because it reminded us that curiosity is still our greatest tool. Wonder is still our greatest fuel. And the universe is still full of secrets waiting for someone, anyone, to look up long enough to notice. Speaking of looking up, if you've reached this point in the story, thank you for being one of the curious ones, one of the people who still feels that spark when the universe whispers. If you enjoyed this journey, tap the like button and subscribe. It helps the channel, sure, but more importantly, it tells the algorithm that people still care about the cosmos. And trust me, you're going to want to be here for the next discovery.